Hello friends and welcome back. Now let's start working on our player, because right now our player cannot move. So to make it move and make the movement sync across the network, we are going to create a new script. So in the scripts folder, I am going to create a new C# script and call it player. So PLAYER. Now also to make our player network, means to make its movement sync across the network and give the player a network identity. Hello friends and welcome to my YouTube channel. So before proceeding to the video, I just want you guys to know about my multiplayer course. So I have created a multiplayer course with over 40 plus lectures, and you can see that it's more than 6 hours of lectures on multiplayer game development using Photon 2, which is the latest version in 2019. So this is the very detailed course, and there are some free videos. You can take that to see if this course is good for you or not. We are going to add a Photon View component on our player. So select your player. So actually rename the player script my player. So delete the old one and create new script, because in the Photon plugins in the demo we already have a script called player. Remove the conflict, just rename it to my player, or you can use the namespaces, different namespaces. So let's open the script in the Visual Studio, and the first thing I am going to do is on my player I am going to add a Photon View. So simply search Photon View. So right here you will find the script and add it on our player. So actually this Photon View script is going to be responsible for the movement, syncing movement across the network. So add that and let's open our script, and the first thing we are going to do is we are going to reference our Photon View. So use Photon View, and to use the Photon View we are going to use the namespace. So using photon.pun, and let's call it Photon View with the lowercase. And also we are going to inherit our class from mono behavior pun, and let's see. So I think the UN should be small. So also now I am going to create some variables for our movement and jump speed. Or let's make it 800. Now because we are setting the jump force too high, so we are going to increase the gravity scale to 5, so our players can fall down quickly. So I have another tutorial on better jumping. You can check that out and implement that functionality to make the jumps in 2D realistic. So I will put the link of that script in the that video in the description, or you can search it on my channel. So let's go back to our script. Now I am going to write update, and in the update function we are going to first of all check if Photon View dot is mine. Now make sure to put the V capital, so you should not confuse it with this reference. So I'm going to actually instead of using photon view, I am going to call it PV. So photon view. Now if the photon view dot is mine, so what this line is going to do, it is going to check if we are the local player. So what is a local player? So let me demonstrate it by using this diagram. So this is the multiplayer game. So let's say this is the PC1 and we are playing the game right here, and this is PC2, our friend is playing with us. Now we are going to have our player, this is P1 this is the local player, and we are also going to have our instance at our friend's PC. Now this is our local player and this is not our local player because it is on someone else's screen. Similarly, we are going to have player 2 on our screen, and this is player 2 which is the local player on PC2. So in the PC1, P1 is the local player because we are going to control it, and on PC2 this P2 is local player and this P1 is not local player. So the photon view is mine is going to check if we are the local player, if we are controlling this local player. So then what we are going to do is we are going to process the inputs. So process inputs, which is the function that we are going to create. So right here we have generated this function because we are only going to process the inputs if we are the local player, because this my player script is going to be applied on all of the players. So if we are going to check, if we are not going to check if this is our local player, then what will happen is we will be controlling both of these players and our friend here is going to be controlling both of the players. So on that instance we only want to move and jump on that player. So that's why we are only processing input if we are the local player. Now if we are not the local player in the else, what we are going to do is we are going to smooth the movement. So smooth movement. Now let's generate that function also. So if we if you have experience with network game, you know that on the network game we have to use the lerp to sync the movement, because otherwise the movement will be very choppy, and to make the movement smooth we are going to use the smooth movement. So you will see in later what this smooth movement is going to do. So let's come back to our process inputs. Now in here we are going to simply get the movement from our keyboard. So I am going to create a variable called move, and we are going to say new vector 3, and we are only going to control the player on the x-axis. So let's put input dot get axis raw, and we are going to say horizontal. So make sure to spell it correctly, and on the y we are going to put the position of our current position. So transform dot position dot y. So whatever position our player has, it is going to be the same. Now next thing is to actually change the position. So transform dot position plus equals, and this is going to be our movement vector into our move speed, and we are going to normalize it by time dot delta time. Now in here I am going to create a new vector 3 variable. So it is going to be a private vector 3, and it is going to be smooth move. Now what we are going to use that smooth move in our smooth movement. So if we are not the local player, then we are going to smooth the movement, because it means that we are not the local player and we are receiving the positions from someone else. So that's why we are going to normalize it, and you will understand it in a bit when we sync our movement. So don't worry if you don't understand it right now. So let's say transform dot position, and it is going to be equal to, sorry, so we are going to use the lerp. So vector 3 dot lerp, and in the lerp you can see that we have 3 arguments. So the first one is the vector a, which is going to be the transform dot position, its current position, and the second argument is going to be our smooth move vector, which we are going to update in a moment. So now the next thing is going to be, if you see here, float t, so time. So we are simply in the time going to say time dot delta time, and we are going to multiply it with, let's say, 7, or make it 10 maybe. So now let's create another function. So for that function we are going to implement an interface which is going to be PUN observable. Now I'm going to explain what this function means. So but right now we are going to implement that interface. So click on the implement interface, and this is going to implement this function. So it is on Photon serialize view. So actually this is the most important function, because using that function we are going to send our positions to next user and receive others position at our instance. So right now if I move, we are going to send the positions to this P1 player that we have moved. So you should also move, so it is also going to move. Similarly, if the P2 is moving, he is going to send the positions to P2, and then P2 is also going to move. So by this way we are going to sync the movements. Now in the function you can see we have 2 arguments. One of them is stream, which is going to be the data that we send, and we have our info. So let's remove that line, and in here we can check 2 things. So if stream dot is writing, and else if stream dot is reading. Now what does that mean? So writing, if we are sending the position, it means we are writing. If we are receiving someone's position, it means we are reading. So right now if I am moving, so my position is updating. So this Photon serialized view is going to send the positions from here, which are going to be received from that. So if we are moving right here on that player, because on both of the player we are going to have the same script. So on the first one this condition is going to be true, and we will send the positions. But at this instance this condition is going to be false, and only this position condition is going to be true, so that he is going to be receiving the position and updating the positions. So let's do the code, and then I am going to explain again. Stream dot send next. So to send the value you can use stream dot send next function, and in here we are simply going to send our position. So transform dot position to everyone else, to every instance. So this is going to send the position to this instance only. Now also if we are receiving, we can receive by using stream dot receive next, and we are going to actually store the received position into our smooth move variable. So we are constantly going to update this smooth, so it is going to be lerp from our current position to newly position. So let's say this, but we are going to convert that stream into the vector3 because the type of stream is object. So right here we are going to cast it to vector3. Now one other important thing about on Photon serialized view is that it is going to only send the value if it is changed. So if the both of the players are standing still, this function is not going to execute. So to decrease the load on network, this function is only going to be executing if the player is moving. So by that way we can save the bandwidth. Now I hope you understand what we did here, so I'm going to explain it again one more time. So let's start here. So if we are local player, we are going to process the inputs through keyboard, so we can update our position using keyboards. So if we are not the local player, we are going to smooth the movement we received. So in the smooth movement, we are going to lerp from the current position, so whatever position we have right now, to the newly position, which is smooth move, which is going to be updated from on Photon serialized view. So every time we received a new position, we are going to lerp to that position smoothly. So let's save the script. So one other important thing that we need to do is, which is going to be very important, so on our player, first make sure to apply the script. So let's drag and drop it on our player. Right here, and in the Photon view you can see that we have observed components. So in that component, drag this my player in the observed components. So if you don't do that, this is not going to work. So this is going to be tell the Photon view to observe that script and update the values and send information whatever is needed. Now after that, so make sure whenever you change something on your prefab, click on the player again and hit apply. Now let's first test the movement of our player. So if I click on play, so you can see that it is acting very weird. So let's disable the camera. So this is because right now this is due to this smooth movement, and because this is a multiplayer game, so we to process the inputs and to check it locally, we are going to actually comment these lines and only going to call this Photon view. So let's do the commenting and let's check it now. So go back and click here. So what might be the problem? So actually the problem was in that line. Instead of using the transform.position.y, just put 0 here so that our y position stays 0. Now after doing that, we need to fix one more thing. So right now you can see that our player is behind the environment. So let's change the order to maybe 2, so our player stays on top. So make sure to hit apply and let's play the game again. Now you can see we have our player and we can move on the platform. So I change this line because I thought this was the problem. So again make it raw. So I hope you know what is the difference between get axis and get axis raw. If not, please check out the official documentation. Now you can see we can move in our scene. So if the movement is too fast, we can do that by putting 6. So it looks good, and in the next video we are going to check the multiplayer functionality. So that's it for this video.